All right. So, welcome back. Continuing our bit of an intro to SASEF. I'm going to talk today about categories in judging. Before I jump into that, just a little bit about me, the person who's going to be talking to you. I'm originally from Portland, Oregon. I'm a physicist all the way through. Physics is undergrad, physics and master's, physics is PhD. But I'm a weird physicist. I do computational biophysics. So I hang around with biologists all the time, and I'm actually a research professor in the biochemistry department here at UT. In terms of SASEF, I've been doing judging for 7 or 8 years. I lose track. I was the vice chair in 2022 and 2023, so I helped organize the judges. And now I'm the chair slash president. So my what I do is a little bit different now. Mark over in the corner is our new vice chair, and he'll be the one organizing the judges and such. But I'm handing the baton this year, so I'm going to help him out when we go through this. So what I want to cover in the slides here today is just a kind of introduction to the SASEF and the ISEF categories and talk about what's similar and what's different between the two of them. And then I do want to take a second and kind of highlight a new category. And then I'm going to have a section where you open it up and I'm going to show a couple example posters and we can kind of play the game of where would you put these for SASEF? And then we can talk about the criteria of the day of judgment, the fair day, what the judging process looks like, and the differences between an engineering and a science, or engineering really is experimental projects, and go over the rubrics. Because there are two different rubrics for our fair. Just to remind you, for SASEF and ISEF, SASEF is the International Science Fair. This year it will be in Ohio, so not too far away. It's not a plane this year on here, it's a nice car. So you send your students to SASEF if you're high school students and they rank the top two. We'll send them off to Columbus to represent SASEF and have a whole lot of fun in Columbus, Ohio. Okay, SASEF categories, or where exactly would my students' project fit? So SASEF hosts 18 different topics. We've got 18 different categories. ISEF has 22, and the SASEF topics, our titles do not exactly overlap with what's going on in ISEF. We'll talk about on the next slide. But just to kind of give an overview here, we're really got a lot of animal science, behavioral and social sciences, biochemistry, cellular molecular biology, chemistry, computer science, and technology and the arts. I want to put a pin in that one. So that one we'll talk about a little bit at the end, because technology and the arts is a bit new, and I want to describe a little bit of what that looks like. Energy and transportation, electrical and mechanical engineering, materials and bioengineering. Material science gets put into the materials section here. Environmental sciences, environmental management, mathematical sciences, medicine, health, microbiology, physics and astronomy, plants, robotics, and earth and planetary sciences. Move my little thing so I can see my own screen. There we go. So you can see we've got quite the breadth of topics here. There's a good chance your project might not fit exactly one topic if your student is doing something multidisciplinary, and we'll talk about that in a few more slides. But we do try to cover as much of the science and engineering space as we can. What's different between ISEF and SASEF? Really, it's just these few that I've highlighted here in red. These are the ones that don't quite fall into one of our categories, but there is overlap. So things like computational biology and bioinformatics, that might end up being, might be chemistry, might be biochemistry, might be cellular molecular biology. It might fall into one of those categories.
But if your student wins and they choose to go in one of these red categories, that's fine.
That's totally fine. Yeah. The common question on the next slide is that, you do not have to if you send a student to a SASEF category, if they win, they can re-put into a different category at ISAF. Uh, embedded systems, this is embedded systems are kind of like embedded computing. So like Internet of Things type of idea. And system software is like operating systems and like that level of technical computer science. Uh, there's a little bit of a difference here in that in our section, we talk a lot about, we've lumped medicine and health sciences together into one category. ISAF actually splits theirs. They have a translational medical science, so things that would directly go into like the clinical work versus biomedical and health sciences. So that's where the split is. Uh, both are still research, but one is going to be like a directly translatable thing, and one is a more fundamental thing. So some common questions that we get looking at this is, we just mentioned one of them. If you pick a SASEF category, it does not need to be your ISAF category. Um, we will help you if you get stumped trying to figure out which you've won in biochemistry, but your project looks like it might belong in cellular molecular biology or might belong in computational biology. We can help you work that out of like, these are what those definitions are from ISAF. ISAF has a list on their webpage of 2021 project titles from different categories that you can use to help guide also if you get stumped. If your project covers multiple disciplines, where do you put it? Well, you kind of just pick the closest you think. And when I say what that is, think about when you read your project, our judges are coming from the entire science community at the UT and Oak Ridge and the Oak Ridge region, like the whole greater Knoxville area. So if you have a project that covers something about yeast, probably put it in microbiology. But if it's yeast related to biofuels production, and you're thinking, well, maybe it needs to go energy and transportation, that might be okay. Just kind of think through, would be somebody that's an expert in energy have had some knowledge of that. So if you're leaning really heavy onto, well, this is a project that clearly is about how to make yields of alcohol higher, then maybe the energy one is better. But if you're talking a lot about like very specific gene work, maybe put it in the microbiology or even consider the cellular molecular biology section. And when in doubt, if you're stumped, we have the science club. So please come visit the science club. Teachers are welcome there as well. It's not just for students. Please come. We will happily chat with you. There's typically board members there, and we will look and try to help you figure out what's a good fit.
Which of the times we just have office hours for the virtual science club?
I'll look that up really quick.
We do have a couple of sessions before the fair where we're just there to answer questions.
Yeah, it's just office hours. The mentors won't be there. It's just people that are helping run the fair kind of work out, oh, that looks like it really should have been this category. Let's help you adjust.
There's actually two this year, Tuesday, February 4th and Tuesday, February 18th.
Yeah. There is that project panic of, oh no, I'm all done. And you get to the day of the fair and you go, oh no, I look at all the other projects there in my category. I've put it in the wrong one. What happens? Don't worry. If it's in the wrong category, because you put a multidisciplinary project and you didn't quite know which one it should go into, and you just took a guess and said, probably goes here. Judges and judge assignments, we try to look at what the project titles are. And if there's an app with the abstracts, we try to gauge a little bit. So when we build the project teams, the judging teams, we try to make sure there's an expert for it. So if we get there and we look at it and all three of the judges look at that project and go, I have no idea for this category, we will pivot. We will find someone to help the judges do that interview. We will find someone to help be the expert to help answer, is that really in the field? Is that really a use? Is that on the innovative section? So when we get to the criteria that's specific to that science, we will find an expert to help those judges work it out.
Someone in our judging panel is either an expert or knows the expert.
Yeah. We will find someone. So do not worry if you get stuck in a situation where you've realized once you got there, oh no, I put it in plant sciences and clearly, I mean, really I should have been in microbiology, and we will find some. So don't panic. So what is this technology in the arts category? This was a new category that SASEF came up with, and it kind of helps cover some of the things that we were starting to see in our own fair as well. This is going to be lumped into our computer science category also. So you're going to have computer science and technology in the arts are going to be together in one category for SASEF. What ISEF describes and kind of what we're looking at too when we think about this category is really 6 different subtopics to it. So you'd have projects that are related to things like displays. Is this a new technology to help you display art or display and convey information? Is it a human interface, interaction with a computer? Is that something like you trained a robot that can talk to you back and forth, so you have this exchange of information, like an AI assistant? Music and image manipulation. So if you've come up with new ways, and this is the kind of the tricky part here, it needs to be technologies that can either create, enhance, or modify how music or images are presented. So don't just go to Photoshop, right? It's not just using Photoshop, it's coming up with new methods that you would imagine 5-10 years from now might be in Photoshop or might be in some other tool to help manipulate the thing. Or the design. Yeah, something like that. Yeah. Games, again, there's a games section now to it, and that's really technology that helps create or enhance interactive sensory things. So like haptic control is a thing that might fit in there. I'm not trying to be prescriptive. I'm just trying to give examples. There will be some,
Question.
Yep.
These are undergraduate, so it's not important here, but just the idea that students are making a game that will help soybean farmers to be sustainable. That doesn't fit there. Is that correct? That would go in plant science.
It would probably go in plant sciences. You might be able to put it here in games if it's maybe not games, actually. That one might be able to go into something like human information exchange to help you interpret data. Maybe. It would probably be better set in plant sciences.
Yeah, because I know that when I talk to the students that I'm dealing with, when they were in high school, they were already making games.
Yeah.
That's the reason I was asking the question. If the game is used kind of as an educational, you might want to put it in the category.
Yeah. If it's some like new UI, new user interface that you've designed to make the game more interactive or to make the information available in a different, unique way, that might fit in the game section here. But just because it is a game doesn't mean it has to go in this section. It might fit better, exactly as Quinn said, into a different category, the category from the information it's derived from. 3D modeling, this is, again, not just opening up Blender and making a 3D model. This is 3D modeling techniques and technologies. So, like.
But if that model was a new way to use an enzyme in fermentation, then clearly modeling is the secondary part. It's biochemistry, maybe that's the important category.
Yeah. So making making an image alone is not the thing that goes in here. It's that you have developed a new technique to make that model, that image. And engineering effects kind of falls in that same section. There is additional things that I kind of made a little example here. Like if you've got a robot that can paint something and you can use that to kind of like highlight how brush strokes work or something, that is an interesting idea. Like that's going to be enhancing the artistic experience. If you can show like, oh, I've programmed a robot that will always paint the same thing and it shows you the brush stroke way it goes along, or you can use it to show how different brush strokes change things. I'm just topping off the top of my head. But things like that might fall in this category too. So that's autonomous devices to help better understand what you're looking at and how to appreciate art. Okay.
Questions, Frank, at UTK.
Yes, this is a new category for all of us. We're still trying to piece it together, and SASEF or ISIF hasn't really provided much more than what I'm showing here in terms of what falls in this space. So if you've got questions about should you put it in something like technology and the arts, or if it should belong somewhere else, please come talk to us. We'll help you work that out. All right. I wanted to do a little bit of an exercise before we got into judging. So these are 3 posters that cover, 2 of them are mine that are bad. They're just bad posters that I put together. And one of them is a poster from someone else that I was also related to on. So also not a great poster. When we get to poster design, you do not want these posters. But for the purposes of trying to figure out what category these might go in, I kind of wanted to open it up to the audience here of like, can we try to figure out where we might put something like this one? This is differential modulation of yeast membrane dynamics under salt stresses with a bunch of computer simulations. So, yep, for that might be a good spot. Biochem might be good. You might argue physics depending on it, but probably would fit better in biochem or cellular biology. It might even go straight into chemistry. So any of those would kind of be a good spot for it. Here's one that might trip someone up. This one is cellulose dissolution. So where would you put cellulose dissolution? Again, it's got a bunch of modeling in it, but that's just the red herring, I think.
You have to explain to me what it is before I can tell you what I think. What does that term mean?
You're trying to dissolve cellulose, like break cellulose down into its singular components. So it's probably biochemistry, might be chemistry. Biochemistry might be a
Plant sciences, because cellulose is the only kind of plant.
it's in bacteria also.
Well, yeah.
But yeah. So you could.
It's most closely related to plant
So
science.
why do you care? Bioengineering.
Yeah. Why you care could be bio. Why do you care? You care because if you break this down, you can make sugar, single sugars. So that makes fuel. So you might say the end game here might be that you put it in energy and transportation because it might be this is a process to help you get a new fuel. Or you might say something like bioengineering. But bioengineering might be tricky because bioengineering tends to be something like you're trying to design an enzyme to break something down, or you're trying to change the engineering process so that like when a plant expresses the cellulose in the cell wall, it's disordered in a different way. So maybe something like chemistry might be good too, because we are talking about all these co-solvent pretreatments. So co-solvents are 2 mixtures of organic solvents. Organic solvents might make you think more chemical engineering. That might put you more into chemistry. Any of the ones we've said, we would probably be able to find a judge that would also have some way of either knowing another judge that has information to help them answer it, or could help you. They could at least get a general idea of how to do it. So that,
even though it's bacteria, it would not fit in microbiology.
It would not fit in microbiology. That would have a lot of trouble there. The same thing with the yeast one. Probably wouldn't want to put that one in microbiology. It's too molecular for that. And then the last one here is improving the accuracy of molecular mechanics force fields for deuterated solvents. So deuterated solvents are just things that go from H to D, right? Might be, I don't know. Where do you think that one might go? Chemistry. I don't know if we go to bioengineering. Yeah, application. Might fit well into, I would argue that would actually go pretty well into physics. because physics is a lot about making mathematical models and improving them for things like liquid properties. Deuteration is going to potentially fall in that. You got molecular mechanics. Chemists and physicists would fight about this one.
Everything with physics.
Yeah, to a physicist, everything's just physics anyway, so it's fine. Just stick everything in the physics category. We'll figure it out. Don't worry. Yes. That is also an option.
That is a strategic.
It is a strategic option. Chemistry tends to have a lot of projects. If you think, yes, if you think that your topic is chemistry related, but has more, your results are more focused on some application, it might be better to go and try to find the category that applies to the application better.
But remember, the most important thing is the student is truly interested in something.
Yeah.
So we'll fit it, students' interest into problem.
Yeah. The student, what helps with the category, if you have something that's complicated like this, is that while we will always find a judge, the conversations that your student might get will vary depending on what category they're in. Because when we try to build the groups for judging, we do keep the category in mind first, then we look at a lot of the projects to kind of assess if we need to move somebody from one category to another. At least that's how I've done it historically. So,
but we ask permission before we move a student project out of the category.
Yes.
We never make the decision that that should be done. That is done at the student level.
Yes. So if that is an important point, we will not move it for you. You have to, we will maybe say this doesn't look like it fits here very well, or we've got judges that are in a different category that might do what that would be a better fit for this. Is your student comfortable moving it? We can do that. All right. And now for judging. On to the judging itself. These are our lovely judges from, well, this was back when we were in Thompson Bowling.
Wow, yeah, that's right.
We're going to need to get a new photo. I think I have hair in this photo somewhere. I'm truncated in the back. You can't see me. That's good. All right. So category judges are always assigned to teams, and they perform judging in 2 cycles. When all the students are off the floor, they're out exploring, they're doing the tours that prep have put in place, or you've got your own activities you've scheduled. Our judges will go out and they will look at and do a brief evaluation of all the posters that they see in their category. They'll make notes to themselves. They may come up with ideas of, I've read that one. Oh, I should really get a good question on that one. I'm a little unclear with that one. That's their first assessment. Your student's first impression is the poster. So that's a big thing to keep in mind. A really good poster does a lot of work for you. If you have a really strong poster that's really interesting, judges really want to come back and talk to that student because they want to know more. If you've got a poster that's a little hard to read or understand, the interview will help. The interview will help a lot. And I have personally been on projects where I've looked at the poster and gone, I don't know. And then I go back and I talk to that student and I'm like, that is the most impressive, brilliant student I've met all year. And I just wish they had made their poster a little bit more clear because their results are great and they're super passionate. But sometimes when you're trying to figure out what questions to ask, if you go in and the poster wasn't very strong to start with, a lot of it's clarification questions at the beginning and you don't get as much in depth. And the student kind of misses out on some of the back and forth that you could get in an interview.
So remember, say the SASEF competition, I'll have strong students with strong posters.
Yeah.
And you can have other things at your poster. You can have the data book. You can have if it is there on the table, the judges will look at that in addition to the poster too.
Yeah.
So you can always extend a little bit by having a very well organized presentation book.
Yeah.
I'm a strong believer in that journey.
I look at the journal all the time.
The journal is really, really helpful. If the poster is unclear, but the journal has clear documentation of what was done, or maybe they have a figure that's on the poster, but it's not clearly just, they don't talk about it very clearly, but they've written a whole page in the book about that one thing. It's super helpful.
Make sure they don't have anybody's picture in there but their own.
Yes. Yeah, that is a big thing, to make sure that they cannot have photos of other people, just themselves.
If there is a picture, let's say with people in the background, if they, do the emoji face over identifiable characteristics, are those acceptable?
Yes.
Yeah, that's fine.
As long as we can't tell who they are.
Gotcha.
We tell them we don't want to know who your teacher is. We don't want to know who your school is.
We don't want to be biased.
Correct.
Yeah. All right.
We try to be as fair as we possibly can.
Yeah. And during the evaluation, both during the interview and during the poster examination, the judges will have the rubric with them. They have access to it. Traditionally, we would print it out. We're thinking about how to make that so they don't have quite as much paper to carry around this time, but they will have access to the rubric and knowledge of the rubric, and they'll be using that to kind of guide their initial evaluations. The keyword there is guide. The rubric is not the end all be all. The rubric is used to help them assess each project individually, and then they go and the judges will get together at the end of the day, and they will take their own individual rankings and compare them. So someone might say, they gave them all 2s because maybe that judge is just really strict about things, and someone else gave them all 4s. They're going to have a discussion about it in the end. So sometimes I've been in a group where someone gave most of the posters 1s, didn't think anything. They did nothing, and they only had like a couple 2s. But they were really impressed with a student. They just happened to give them a 2. And I had given them like a 4. Because I'm like, but that poster was really good and that discussion was really great. And he's like, oh yeah, it was absolutely great. I totally would put that person as number 1. Like, why'd you put him as a 2? It's like, oh, because I just did, that's how I ranked them. I didn't think they belonged at the 4. So the point score is not really what matters here. The point score is so the judges, for their own sense, are looking and judging on the same criteria. And then they will get together and they will deliberate. So one judge's 2 might be another judge's 5.
Another thing I have seen that judges will notice different things. When they collaborate, they will talk about strengths and weaknesses. And sometimes I will realize that I didn't understand something another judge understood, and I will find that that's superior to the way I thought about it. So I'll change my score.
Yeah.
So it is a dynamic process to finally come to an agreement on a ranking of those projects.
Yeah. We don't just put the judges' scores in a spreadsheet and whoever gets the highest score goes. Some fairs do it that way. We're very holistic.
Yeah, we want to make sure that we account for internal biases for the collaboration.
Is a very large part of the end process for picking the ranking.
Yeah. It's part of the reason why we make them stick around for dinner. Yes. Okay.
Here just finished their development. So
yeah, we've recently updated the rubric for this year moving forward. So a lot of deliberations over exactly what should go into it. So warning, the actual rubrics. So it's not 1 rubric, it's 2 rubrics. And you might be surprised it's not a different rubric between junior and senior level. No, the rubric is actually differences are between if it's a science, more experimental project or an engineering design project. So computer science, engineering, and math are going to fall under the design and logic principles section. It's more engineering based, and everything else is going to be under the experimental section. So what does that look like? Well, we've got 6 criteria. So project design. So before I get too far into it, before I forget, of the 6 criteria, 3 of them split between experimental/science and engineering, computer science, and math. The other 3 are the exact same criteria for both sets of projects. So criteria 1, 2, and 3 are split between experiments and more engineering-like projects. This is online.
Virtual science clubs.
Yeah.
So, Mark and Nicholas are historically at those meetings.
Yes. So the biggest difference between an engineering project and an experimental project, and this is one we really want to stress because a lot of times, sometimes engineering projects will put down a hypothesis and then we have to grade it as an experimental project instead, is that the engineering projects don't have a hypothesis. They are design driven. They're written by, you have a design brief that you have made very clear, and you have a measurable performance goal. So I want to engineer something that improves yield by 10%, or I need to reduce the cost of making this by Y%. That's the type of thing you're looking for with the engineering ones. CS and math sort of fall in that range too. Some math ones, it's a lot of times it's people talking about how they can improve something. So it's kind of working out like, well, how did you come up with the idea to do the proof? And then what's the plan? This ties more to background for the math projects, but math will get evaluated in this way too. They don't typically have a hypothesis they have to test. Experimental projects, we have a few more things we look for than we do in the engineering ones on the first project design part. Really we're looking at, is your experimental design presented in detail and is reproducible and efficient? That comes into a different criteria point for the engineering ones. It's still part of it, but it's not part of the project design component. Criteria 2 is data collection and documentation. So again, in an engineering project, you might be collecting data, but your overall aim is not to collect data to test a hypothesis. You are maybe doing it as like a sanity check for something, or you're using that to help. You want to document all the things that you've done for it. So really it's more the documentation of the information that's coming out from an engineering project. Data collection work from the experimental one is you want to make sure it's extensive, it's relevant, it's really well presented. Whereas the engineering ones, we're looking for things like a discussion of the considerations that you have at the beginning, for the end of the project, and how the design is influenced. If you want to try to get flow charts describing the factors that lead to your final design choices and what the final design actually is. And then a big one that these are all technically of equal importance, but one that I have found doesn't always show up when we look at engineering projects is suggestions for how you can make it better. So, during the interviews, students typically do that very well. If you go to an engineering students project and they do like, I came up with a new way of making a bridge and it's really cool. And they've talked about all the details behind making the bridge. And then nowhere on their posters that say how they could make additional modifications to their project. They'll typically be able to answer that question in an interview, but having that also included in things somewhere in either in the book, your journal book, or somewhere on the poster, that's helpful, because then it helps the judges already know that you've been thinking about that. Now, these are more topic specific. So really in the science ones, experimental ones, we're talking a lot about how the presentation and analysis of the data is done. And on the engineering side, you're looking at the testing and confirmation that like your design worked the way you had it was supposed to work. So this is kind of where more of that this proof section that it's reproducible in the manner it's presented comes back into the engineering one. So reproducibility kind of showed up earlier in the science criteria, and experimental criteria. It comes in the criteria 3 for this one. And this is also where some of the experiments are. Yes, time. Okay. The last 3 are ones that are in common with everybody. This is your background. You want to make sure that they can talk about the topic in ease. Everything is defined. Do not leave hanging definitions, please. And if bibliographies are provided, that's another big one. Poster. There's a whole section on posters coming next. So I'm not going to talk too much about posters and poster design, but just know that the poster alone is a criteria. So everything else that we've shown before goes into the poster, but the poster design itself is part of the criteria. And then the kind of tricky one to sometimes judge, but sometimes it's not tricky at all. It kind of depends on how the student's question is in their project. Is the creativity and ingenuity is the project creative and original? Do you have a clear interest in the subject? And is there a unique approach to solving the problem?
This doesn't mean you have to have conference.
No. You don't have to make it unique for the sake of being unique, but you need to make it so that it's not a repeat of what was something else already in the literature. It's not, you didn't go to one of those books that say 101 science fair projects and repeat one of those.
In middle school, essentially what we're doing.
Yeah.
So does this come into judgment? I mean, I know it does, but you will have
Everything is age appropriate.
Yeah.
But I mean, because in middle school, it's essentially we're going to, science studies and 101 new experiments you can do in home.
But they can put their spin on it.
That,
right?
yeah.
Right.
So we're just looking for spins.
Spins at this level. We're not thinking about like a whole new plan.
But not at the expense of understanding the scientific principle.
Right.
Yeah.
Right. That's what we're doing. We're trying to make sure they can get through a project.
Yes. That.
The comprehensive way.
Yeah, and if they've done a project that we've all seen before, like pouring different liquids on a plant and measuring the growth,
Right.
they're not gonna get as many points here, but that doesn't mean it's a bad project. It doesn't mean it's not gonna win. It might be the most well done. That kid actually grew 10 plants instead of 1 plant.
Yeah.
And they understood.
Right.
Yeah.
Those things are heavily.
Yeah, so spin at like the middle school level here would be like, if you took one of the 101 ones, you would say, okay, they only did 3 samples. I did 8 samples. Or they did only 2 colors for color test, and I do like these 4 or 5. Or they use these colors and I use these other ones. Or
Yes.
That's the kind of spin you want. So
Have them use the idea, but make it their own.
yeah. If it
Making sure I was.
yeah, if it looks like something that was exactly what the book said to do, that's not super, that one hurts. But if it's something like I took it and then I added to it, or that part seemed a little odd, so I swapped it for this one, or I took these 2 ideas that are next to each other in the book and I figured out how to put them together in a way that made sense. That's the tricky part with it sometimes, is making those 2 make sense together. That's perfectly valid. That's exactly the kind of thing we're looking for at uniqueness for the middle schools. If you get something that's completely unique, that's also fine.
Yeah.
That's even better. That's going to rank higher on this one.
That's a great place to use our visuals in our virtual science. Come in and say, hey, I've got this idea. I want to build on 101 science fair projects, and how and what we'll ask them is, well, what are you interested in? And they'll tell us, and we'll work together and get them to use some kind of unique question.
Sometimes they'll see a technique in those 101s, and they're like, really understand that technique. They thought like that gets cool, or they did the experiment in class already, but then they were like, but I want to try it on this thing I have at home instead. Like I did this with rocks in class, but now I want to do the same thing with glass or something, or plastics. That's completely fine. That could rank high if it's a very like you applied something that you wouldn't think to try, that could be a really interesting project in itself. All right, so we've got a little bit of time for Q&A. We've already kind of done a little bit of it. Before we do the Q&A, I'm going to just jump one slide so we can get it in the recording, and I'll go back to the Q&A. We have the judging rubric online. If you go, I put the whole big gigantic tape web address in there. But if you just go to the if you search for UTK SASEF and you click on judging, you'll find the judges rubric. And this is the updated rubric that will be online. I didn't talk about it because I didn't want to spend a whole time digressing into all the different rubrics that exist for the national awards that exist. But if you have a student that is really interested in a special award, they have a topic that they think is really cool, and they happen to go on and see that, like, oh, last year someone won an award for best such and such project, best project in earth sciences, or best project related, not earth science, but like a NOAA project. And you want to know what that actually entails, what those types of projects look like, you can click on, if you go to societyforscience.org and you look at the ISEFs, they actually say what the regional award material is. And you can look up what those regional awards are for the year. And they change every year. Sometimes there's a lot that stay pretty common, but there's some that swap out a lot. Like the Navy is almost always there. But there have been some, like Regeneron wasn't there one year, I think, and they were again. So they change around, like biomedical ones change it out. And those vary in the size of the award also. And then there's additional resources for teachers and the teacher resources that have some Q&A stuff you can use to help as well. But we got, I think, a minute before the poster session starts. So if there's